So we're going to use this first function to answer these several questions. So find the average rate of change. What does that mean? Just average rate of change. You can type it in the chat. What does that mean we're going to find? Good, slope. All right, we want a slope between 1 and 3. That's our interval. So if we plug 1 into this function, let's see that we 3 plus 5 would be 8, minus 2 would be 6. And if we plug in 3, oh geez, 3 squared is 9, times 3 would be 27, plus 15 minus 2. So what is that, 40? Am I adding that right in my head there? There we go, 40. All right, so to do your slope, it is going to be 40 minus 6 over 3 minus 1, and just do nothing to that, please. Just do nothing. If you make a mistake, then it'll be wrong. So just leave it alone. All right, and then number 2 was the longest one. This is a lot of algebra here. Limit h goes to 0. First thing we're going to do is plug x plus h into this function. Now be careful because there's 2 variables where you have to plug in x plus h. So it's 3x plus h squared plus 5x plus h minus 2. And then we're going to subtract the function. And then that is all over h. Now, yes, pep talk, this next step is going to be long, okay? But we can get through it. And you will catch any mistakes you make because stuff won't cancel out if you make an error. And then you'll be like, oh, I had a mistake. Now this x plus h squared, again, that means x plus h times x plus h. If you work that out off to the side, you're going to get x squared plus 2xh plus h squared. That one you tend to do a lot, and probably, I think this is the 3rd time I've done it in our class here, so probably end up just sort of knowing that one. And then we're going to distribute a 3 into that. So that will be 3x squared plus 6xh plus 3h squared. So that takes care of this first part. Now we're going to distribute the 5. So that will be 5x plus 5h. And then we've got a minus 2. It's kind of just hanging out there. And then distribute this negative sign through the parentheses because you want to subtract all of that. Phew, okay, hard part's done. Now we're looking for stuff that goes away. All right, so what is going to cancel out here? Hopefully a lot. All right, good, we've got those. And the 5x's. And the 2's, good. All right, now every term that's left, all 3 of these, you can factor an h out of. I would not skip this step. People that try to skip this end up losing part of their answer. Also, you remember you have to plug in 0 for h. So it's only the 3rd step, just write it out. All right, taking out an h, you'd be left with 6x plus 3h plus 5. And so the h's cancel, and then here is your derivative. We're going to plug in 0 for h, so that's gone, and it'll be 6x plus 5. So that is our derivative. So find the instantaneous rate of change at -2. That just means evaluate the derivative at -2. So all you've got to do is plug -2 into this. That would be -12 plus 5, so -7. And that means the slope of that tangent line would be -7 at that point, -2. So 4 says, write the equation of the tangent line at 3. So to write an equation, you need a point and a slope. So we need to plug 3 into the function to get our point. And I think we already did that one up here. Yeah, when we plugged in 3, we got 40. But if we hadn't done that one already, we would just plug 3 into the function, see what we get. Slope comes from derivative, so we want to plug 3 into the derivative, so f prime of 3. So we're plugging 3 in right here. So that would be, 18 plus 5, so 23. And so here's your point, here's your slope. We're going to write the equation. So y minus 40 equals 23, parentheses, x minus 3. And then these last ones, we're going to use the chart. So the chart problems are great because you don't have to do any of this. All of your values that you need are literally just right here. So this says average rate of change of f. And I think I only gave function f. Yeah, there's not a function g for this one, so you can't mix them up. Average rate of change of f on the interval 1 to 2. So that means slope from 1 to 2. So we need f of 1 and f of 2. So f of 1 is 2, and f of 2 is 1. I didn't mean to make that confusing. I typed a bunch of numbers in, and I guess I wasn't paying attention. I just made them all up. They were 2s and 1s. That's okay. This is what we got. And so when you do your slope, it will be subtract the y values, and then subtract the x values. So your numerator is -1, denominator is 1, so just -1. But actually, I don't know why I got really excited to, simplify that down. You could just stop there. You don't have to do any of that. Right, and then last one, write a tangent line equation that will allow you to approximate f of 2.9 and then do the approximation. So where do we want our point of tangency to be? Cool, 3, because 2.9 is really, really close to 3. So I need my point, I need my slope. And unlike this question up here where we had to do this whole derivative in order to plug in and get the slope, and we had to plug into this function and figure that out, all our values are right here. It's great. 3, 8 is the point. And then the slope comes from the derivative, so that'll be f prime of 3. And this is my f prime column. F prime of 3 is -2. And so my equation is y minus 8 equals -2, parentheses, x minus 3. And then to do the approximation, all you have to do is plug in 2.9 and get y by itself. So plugging in 2.9 will look like this. And then I just have to add that 8 to the other side so that y is by itself.